All right, chemistry. Hello, hello. This is a new video for the last topic in Unit 3. Yes, we're still on Unit 3. We're going to start predicting products today. This is the first video of at least 2 and maybe 3. In this one, we're going to be focused on splitting up the reactants, normal compounds, for double replacement reactions. So this video is just going to be how to split stuff up. This is worksheet 6. There is a picture which looks like this, and then there is a Google form where you can actually enter your answers as you're going. And tonight or tomorrow morning, I will go through and I will add a key to that so that you can check those if you're doing this from home or doing it late. Now, predicting products, there are 3 types of reactions where we'll be predicting products. Those are double replacement, single replacement, and combustion. Double replacement is what we're going to work on today. In single replacement, it just changes one step just a little bit. So when we go to switch over to single replacement, I'll have one video where just real quick we knock that out. Combustion, the products are always the same. It's always carbon dioxide and water. And you guys all know that already, so that shouldn't be a problem for you. You just write down CO2 plus H2O. So today we're going to start with double replacement. Now, I am making an assumption in this video. I am assuming that you know your polyatomic ions. You have to know their formulas and their charges, because if you don't, you're not going to be able to properly balance stuff or unbalance stuff, as the case technically is today. So if you don't know those, it might be a good idea to pull up a list of those while you're working on this worksheet to help you out, because this worksheet is going to be really difficult if you don't know your polyatomic ions. So let's start with number 1 here. And actually, before I do this, every time you split a compound up, whenever you're predicting products, the first thing you have to do is break a compound up into a cation and an anion. Every ionic compound is one cation bonded to one other anion. Well, every compound we work with in this class is one cation bonded to one other anion. So what you have to do is identify that cation and the anion from the compound before you can actually separate them out. So here's your first tip. The cation is almost always one element. Okay, and that one element is going to be either hydrogen or a metal. Now, it is possible to have a polyatomic ion as a cation. There is only one polyatomic cation, and that is this one right here in our first example, ammonium. NH4 is the polyatomic ion ammonium. So I'm going to write NH4. And since we've memorized our polyatomic ions, we know that the charge of ammonium is +1. So we're going to put that down as well. Okay, so that is the cation. The anion is what's left. So all of the elements that are left over are part of your anion. So they're going to go at the rest of it. Now, this is another polyatomic ion. OH is hydroxide. And we know that hydroxide has a charge of -1. So we can just write that one down. Now, for the second compound, which is hydrogen sulfate, based on the name hydrogen sulfate, this 2 has been added. Okay, it was added to charge balance. So based on the name hydrogen sulfate, we would have HSO4. But H has a +1 charge, and sulfate has a -2. So in order to charge balance the compound, we have to add a 2, so that we're taking +1 times 2 to give us a +2 charge to cancel our -2. Because this subscript had to be added as a charge balancing subscript, it does not come along when we write it down in our list. So the cation in this compound is not Hang on. I'm going to wait for the bell to stop. The cation in this compound is not H2. It's just H plus 1. Okay, and then because the 2 is just saying we have 2 of these. Okay, this 4 came along because it's part of the polyatomic ion formula that you memorized. So anytime you have a single element, you should not have any subscripts attached to it. Not in this class. Now, there are some polyatomic ions out there that are like that, like peroxide, but we're not messing with that in this class. So that brings us to our anion, which is SO4 negative 2. So that is what you need to write down in the Google form. Now, on the Google form, you can't do subscripts and superscripts. So the way I actually want you to enter these would be like this. So we have NH, our subscript. You'll just type, put a space, and then type out the charge. Then put a comma and do the next one. So then for anions, it would be OH negative 1, a comma, SO4, a space, negative 2. So that's how I want you to enter them in the Google form. Now I'm going to do 2 more with you. I'm covering my face with my marker. I'm going to do these 2 with you, and then the rest of these, there's 12 total, so the other 9, you're going to be on your own for. Now, again, I will enter the key later so that you can go through and check your answers. If you have questions, ask. Tomorrow is quiz retakes. Tuesday next week, we're moving on. So you need to know how to do this before Tuesday next week if you're stuck. So in this one, or in this equation, our first element is Na, sodium, which is going to be our cation. In this one, lithium is our first element, which is going to be the other cation. So sodium, Na, goes here with a +1 charge, then a comma in lithium, which is also +1. Both of those are +1 because they are in group 1 on the periodic table. So if we look here, lithium and sodium are both in the first column. And everything in the first column has a charge of +1. Everything in the second column always has a charge of +2. The other 3 that you're supposed to memorize are silver, which is always +1, zinc, which is always +2, and aluminum, which is always +3. All the others you have to figure out based on what they're bonded to, which is why it's really important to know your polyatomic ions. So next are anions. We're going to have hydroxide again, so OH, negative 1. And then the second one is BrO3. Now that is bromate, which has a negative 1 charge. Now, for the third one, we have iron. Iron is not one of those 15 elements that I just mentioned that we know the charge for. Iron has 3 possible charges. It can be a +2, a +3, or a +6. So we have to figure out which charge it has based on what it's bonded to. So if we look here, hydroxide, we know, has a charge of -1. Since hydroxide has a charge of -1 and there are 2 of them, our total negative charge has to be -2. So if we have a total negative charge of -2, our positive charge has to be +2, because these have to cancel for an ionic compound. So since there's no subscripts here, or rather there is a 1 subscript here, this has to be a +2. So we'll have Fe +2 for this one. The other side we have calcium, which is in group 2. So that's going to be Ca +2. Anions, we just said hydroxide is -1. So OH, -1. And the other one, CO3, is carbonate. That's one of the odd ones, I'll admit. Carbonate has a charge of -2. And that's all there is to this. We're just breaking them up and listing the cations and the anions separately. So that's it. This is the only part of this worksheet you have to do. I am going to be adding a new section to this worksheet this weekend. You do not have to do that until after lecture on Tuesday. Okay, and I need to remember to mention that to my chemistry students in class tomorrow too. Okay, but you do not have to do the second half or the last part of this worksheet till tomorrow. So that's it for this video. Again, let me know. Shoot me a message. Shoot me an email. Comment on this. A few of you have done that, and I will get a hold of you to help you figure out what's going on if it's not making sense. So that's it. Have a great night, and I'll see y'all back in class one day.